Hey guys, in this video we're going to talk about what a conjugate is and how we can use it to rationalize denominators in different expressions. So a conjugate we define as it's two binomials that are in the form a times root b plus c times root d. So that would be one, and its conjugate of this expression would be a times root b minus c times root d. So these two we would call conjugates of one another. The first term, notice, stays the exact same, and all you're going to do, instead of adding the second term, you're going to subtract, or if you were subtracting, you're going to add. So I'll show you some examples of what conjugates are, and then we'll see a special property of them and see how we can use them. So let's start with a simple one. Let's say we have 2 plus square root of 3. The conjugate of this would just be 2 minus the square root of 3. And a special property that happens between them, if you took these two binomials, so 2 plus the square root of 3 and then 2 minus the square root of 3, you might recognize, it should look familiar to you, it's a special product here. You're going to do, if you do FOIL, 2 times 2 is 4, 2 times minus square root of 3 is minus 2 square roots of 3, 2 times plus square roots of 3 is plus 2 square roots of 3. Those two terms are going to cancel out, and then you're going to have minus the square root of 3 squared, which is 3. So you'll end up with 4 minus 3, which is 1. So a special property of conjugates is when you multiply those two binomials together, their product is going to get rid of all the radicals that could be there. So that root 3 is now going to go away. The product of these two conjugates equals just 1. And you could have other, like if you want to do some other practice, like maybe you had 9 times the square root of 5 minus 4 times the square root of 2. The conjugate of this would just be 9 times the square root of 5. The first term is going to stay the same, but the second term, all you're going to do is change the sign. You're going to add instead of subtract it. And if you were to multiply these, all of your radical signs are going to go away, which is going to be really nice because when it comes to rationalizing denominators, that's what our goal is, to get the denominator to be rational. So we'll be using the conjugates today. So our first example that we want to simplify, we want to write this expression in simplest form. So in order to do this, we're going to use the conjugate, and just like we did in our last video where we were trying to get rid of the radical sign down here, we multiplied, like if this was just radical 2, you'd multiply by radical 2. So we're going to multiply by the conjugate. So instead of 5 minus radical 2, we're going to multiply by 5 plus radical 2. And we're going to multiply the top and the bottom both by that, because like we did in the last video, this whole expression is equivalent to 1. So it's like we're multiplying by a value of 1, which isn't going to change the value of our original expression at all, but it is going to rationalize the denominator. So if we do on top first, you're going to have 3 times this binomial, which will result in 3 times 5, which is 15, plus 3 times square root of 2, which is 3 root 2. Then on the bottom, I'm going to do the work over here. You're going to have 5 minus the square root of 2 times 5 plus the square root of 2. Again, these are the conjugates. Our whole purpose of using these is to get rid of those radicals. So 5 times 5 is going to be 25. We should know those middle terms are going to cancel out. So we're going to end up with minus the second term squared. This is why it's a good thing to have those special products from earlier in the year to really be familiar with them. This is like, remember we had this earlier in the year, a plus b times a minus b equals a squared minus b squared. It's a difference of squares. So we're working with that here. So it makes it a little bit easier to do. So this will be our final expression. 15 plus 3 times the square root of 2 over 23. And notice we are in simplest radical form now. So on to our second example here. In this example we have 4 times the square root of 2 divided by 6 plus the square root of 6. So the only problem with this not being in simplest form is that we have this radical down here in the denominator. So again, we can use the conjugate. So instead of 6 plus the square root of 6, the conjugate would be 6 minus the square root of 6, and we'll multiply the top and the bottom by that. So up top we end up with 4 root 2 times 6 is 24 root 2, and then 4 root 2 times negative 6 would be minus 4 root 12. We can simplify that. We'll do that in our next step. On the bottom, we're going to have 6 times 6 is 36, and we're going to end up subtracting that b term squared, which would be minus 6. So I should have room down here. We're going to have 24 root 2. Can't simplify that. Over here, we can simplify the 4 root 12. Remember, square root of 12 is like 4 times 3. It's like 2 root 3. We have the 4, so it's minus 8 root 3. And on the bottom, 36 minus 6 is 30. Clear this up. You might look like you're in simplest form here, but we actually can reduce. If you look at your terms up top, we have 2 terms. You have 24 root 2 and 8 root 3. They're both over 30. You can kind of think of it like this, but as you get better and start to recognize this, you won't have to do this. But each term up top is being divided by the 30, and then just look at the fractions. 24 over 30 can be simplified. They both are divisible by 2, so you're going to have 12 over 15. Then over here you'll end up with 4 root 3 over 15, so you just end up with 12 root 2 minus 4 root 3 all over 15. Just by looking at this though, you should be able to go from here to there. Look at what you have in common between those 3 terms. You have a 2 in common with all of them, so they all can be simplified down. Alright, so here's your final simplified version. And we can't combine those 2 square roots because they don't have the same radicand inside them. Alright, our next one, and then you'll try some on your own. This one's going to have a couple of radicals in the denominator. So we have 5 over root 6 plus root 3, and we want to simplify. So we can't do any simplifying in the numerator or denominator. We can't combine these, but we can use the conjugate. And remember, the conjugate, a stays the same. That first term stays the same, and your second term is going to become minus whatever it was. So minus the square root of 3. So the square root of 6 minus the square root of 3, that's the conjugate of this. Up top, you're going to have 5 times the square root of 6 minus 5 times the square root of 3. On the bottom, you're going to do 6 times square root of 6 times square root of 6 is 6. And you're going to end up with a minus that b term times itself. So you'll have minus 3. If you ever forget that rule with the difference of squares, you can just FOIL out, but you're going to end up here when you FOIL out. And you'll have 5 root 6. Let's clean that up. 5 root 6 minus 5 root 3 all over 6 minus 3 is 3. Can't simplify any further, so this is in simplest form. Alright, on that last slide, there's 3 problems. If you want to try them on your own, you can go ahead and do that if you want to pause. And I'll go through them right now so you can check your work when you're done and come back and see if you got the same answers. So our first example on that last slide is 7 over 5 minus square root of 3. And we are trying to write this in simplest form, so we've got to get that radical out of the denominator. For this example, in order to use that, we need to use the conjugate. So it's 5 minus the square root of 3, so we're going to have 5 plus the square root of 3. And we'll multiply the top and the bottom. So on top, you'll have 35 plus 7 times the square root of 3. And on the bottom, you're going to have 5 times 5 is 25. Then those middle terms would cancel out if you FOILed, and you'll end up with the last term, that root 3 times root 3 is 3, and you're subtracting it. So we should end up with 35 plus 7 root 3 all over 22. And that is in simplest form. Our second problem here, we have, let's get this out of the way, we have root 6 over root 3 minus root 2. So we need to get these radicals out of the denominator, and again we can use the conjugate. Root 3 plus root 2, root 3 plus root 2. So on top we're going to end up with, and we'll do a couple steps for this, you're going to end up with root 18 plus root 12. And on the bottom, you're going to have, well, root 3 times root 3 is just 3. And remember, those middle terms will cancel out, so you'll have minus negative root 2 times root 2 is going to be minus 2. So you'll end up with a 1 on the bottom. So it'll be over 1, so I'm just not going to write over 1 anymore, which means, let's go this way, you have root 18 plus root 12. And we can simplify those. Root 18 simplifies to 3 root 2, and 12 simplifies to 2 root 3. So in simplest form, 3 times the square root of 2 plus 2 times the square root of 3, that is equivalent to our original right here. All right, and our last one is this guy right here. We have 4 times the square root of 10 over 12 plus the square root of 5, and we want to simplify right in simplest radical form. So we'll use the conjugate, 12 minus the square root of 5 on top and on bottom. And then let's do on top first. 4 times 12 is 48, so we have 48 square roots of 10. Minus, let's see, we'll have minus 4 times the square root, we'll end up with the square root of 50. We can definitely simplify that, which we'll do in our next step. Then down here we have 144. That is your 12 times 12. The middle terms will cancel on your FOIL, but you'll have minus 5. So all we need to do is simplify. On the bottom you should have 139. On top, left term we can't do anything, but the right term, square root of 50 is 25 times 2, so you're going to take that 5 out, so you'll end up with minus 20 and root 2. And this right here, we can't simplify any further, so we are in simplest form right here. Alright, so that's how you can use a conjugate to rationalize a denominator. It's good to know what a conjugate is. It'll help you whenever you have not just a radical down here, but a binomial involving a radical. Alright, that's all we have for the day, so go ahead and try some on your own. Have a good day.